The dual capacitor paradox. Look on Wikipedia, they'll say transferring it to heat, or making wireless radiation and radiating into the air, and why you lose so much. So I'm going to explain what is happening here. A lot of people think there's free energy involved in this process, so I had to investigate it to come up with my conclusion on the matter, and I reached my conclusion of exactly what's happening with the dual capacitor paradox that Wikipedia seems not to be able to understand and explain accurately themselves. So let's just dive in here. So basically, if you take one capacitor with, say, 20 volts, and you dump it right into another capacitor directly that's empty, okay, the voltages are going to balance. On one side you'll have 10 volts, and on the other side you'll have 10 volts, because voltages like to balance. All right? But when you figure out how many joules that got transferred, you realize that you transferred 15 joules and you only caught 5. You lost 66% of your joules that you transferred. They vanished. Right? So you could only catch 33% in an empty capacitor. So people try to explain why, and they don't really have an answer. And the home experimenters noticed if you put a motor in between these two capacitors and you do the same thing, it catches, or it captures, the exact same amount of joules. And in the process, it spins the motor. So they assume that you're getting free work because you're catching the same either way, but the other way, you spun the motor. What the heck? How did it get power to? It's pulling it out of the vacuum. It's pulling it out of the ether. Anyway, let's get to what's happening here. Okay, so over here we have, where's my mouse? Here it is. You have a capacitor filled up to 20 volts. Let's call the purple units volts. All right, from 10 volts is halfway. So the average between 20 and 10 is 15. So let's call this joules. Okay, so it is 15 joules. So in the top half of the capacitor is harnessing 15 joules of energy in there. And in the bottom half, the average of 10 and 0 is 5. We're harnessing 5 joules. So we have 20 joules total. 15 of them are being stored up here, and 5 are being stored down there. So if you have an empty capacitor next to this one, right, and if you connect these together, the voltages are going to balance. They're going to end up with 10 units or 10 volts in both of them. But you sent out 15 units to balance it, and at the end, the one you catch in only has 5 units. So 5 is 33% of 15. You lost 2/3 of your energy transferring this 15 into another capacitor. It's gone. Now, as I said earlier, you take that same 15 joules, well, 20 joules, and you transfer 15 of it through a motor, you still catch 5, but the motor spins. And is it spinning for free? Okay, so here's what's happening. The difference between 15 and 5 is 10 units or 10 joules. Now, that's what the motor's spinning with, that lost power. The power that you lost transferring is being consumed by the motor now, and that's all it gets. So the difference between the 15 and 5 is 10 joules. The motor's spinning with the 10 joules, and it's still collecting the other 5. But you're not spinning the motor at the full 15 joules. How can we prove this? It's pretty easy. Do the same exact test, putting 15 joules directly into a motor. So just get one capacitor, connect both the red and the blue lines, the negative and positive, right to the motor, no second capacitor, and send out 15 joules to the motor. Now time how long it spins, or count rotations, however you want to measure the power. See how much torque you're getting in that motor, how long it spins. In my case, I did it on a smaller scale, but I got 4.76 seconds of spin. Then you hook up a second capacitor, redo the test, send out 15 joules and catch 5, and time how long it spins. On that test, I got 3.14 seconds. Now, you take my averages. 3.14 is 66.6% of 4.76. The motor only spun at 66% as long as it does when you just send the joules directly in there, because the other 33% was caught by the capacitor. So the math isn't too hard once you untangle it to figure out whatever size capacitors, how much, and how much you could use. But basically what it's saying is, yes, you were losing energy, transferring from one capacitor to another based on how these average and how capacitors hold energy. But that energy can be harvested back and not lost in between the two with a device. I'm not saying 100% because you're going to lose some in resistance and whatnot. But if everything was 100% efficient, you could get that 10 units back by putting a little generator there and collecting the 10 units, a little windmill, something like that. You could get that back. But you can't get more than 10 out of this if you caught 5. Now, you could repeat this experiment 100 different ways, but that's what's happening with the dual capacitor paradox. I hope that clears it up, that the energy is there to use but can't catch it. But it's not in addition to the energy that's in here. You can't get more out this way. This motor is not going to spin at 15 joules worth of power and catch 5 of it. It's only going to spin at 10 joules worth of power, because the differential, if you put a multimeter on, measure the differential, there's going to be a differential of voltage, and that's what the motor's running on, the differential of voltage in between these two, where it starts out nice and quick and then it slows down because the differential starts closing. Now, a capacitor and a regular battery, a battery and a motor in between two positive sides of a battery is doing the exact same thing. Exact same thing, whatever. It's robbing from Peter to pay Paul. So that's what's happening. Yes, you can charge a battery and run a load in between charging that battery, but when you work it out, what's coming out of the main power source, it's being divided equally in between the two, right down the line. Now, I could go over all that math and the hundreds of tests I've done measuring what's coming out of a power supply, what's coming out of a car battery, what's coming out of a 6-volt battery, what's going in, what's going into the load, and evaluating it at every angle, seeing if there's a little point to harvest at. And unfortunately, I don't see any benefit or possibility of catching anything that wasn't there with the whole recycling thing at the moment. I am looking into other things about it. It opens up your eyes to how electricity really is working though, so it gives you more understanding to experiment with this stuff. So I don't recommend or believe that the books have it all right. I do think there's a lot that needs and should and could be discovered still. So we'll see what my research brings me. But that's the dual capacitor paradox. And especially when you're spinning a motor in between them, that's what's happening, and I hope you enjoy.